In this video, we're going to be talking about how to convert degrees to radians and radians to degrees. But first, I want to look at where this conversion is coming from. Let's say that I have a circle with radius r, and I want to look at this angle that's going to go all the way around. Normally, we would call that 360 degrees. But if we're in radians, remember that we have to use this formula over here to measure the angle. So this angle theta is S over R, where S is the arc length. Well, if I'm talking about the distance all the way around the circle as being the arc length, we also know that as the circumference. And we know the formula for the circumference is 2 pi r. So substituting, we have 2 pi r over r, so the r's are going to cancel out. So I have theta equals 2 pi. So this distance all the way around the circle, or this angle measure that takes me all the way around the circle, is 2 pi radians. Well, that one revolution all the way around the circle is 2 pi radians. So I can also say that 360 degrees is 2 pi radians. Now, if I divide both sides of this equation by 2, I have 180 degrees is pi radians. And if I divide both sides of this equation by pi, I have 180 degrees over pi equals 1 radian. So I can take this ratio and flip it upside down and have pi over 180 degrees. This is the ratio that I would be using to convert degrees to radians. Now, I know that pi is approximately 3.14. So if I were to divide 180 by pi, I get approximately 57. So 1 radian is approximately 57 degrees. What I want to do next is look at a different way to relate radians and degrees. You can see I have a circle with the radius drawn in, and I'm going to go ahead and draw in the rest of this diameter to sort of dot that in. And I want you to recall that this length of this radius, I can take it and put it along this outside circumference, and this measure here would be r as well. So I have one radius measure that I have put along the circumference. And I'm going to continue putting along these radius measures all along my circle. Hopefully you can see here that I have 3 radius measures that I have sketched in along the top half of my circle, and I have just a little bit extra right in here, right before I get to that diameter. And we're going to come back and talk about that little bit extra in a minute. So I'm going to continue filling in my circle with radius measures along the circumference. So you can see here that I have 6 radius measures that go along the circumference, and then I have a little bit extra right here. The distance all the way around the circle is 2 pi. So we have 2 pi radius measures that go all along the circumference. And 2 pi is approximately 2 times 3.14, which is approximately 6.28. So I have 6.28 radius measures along the circumference. So this orange part in here is that extra 0.28. I've got 6 full radius measures and then a little bit extra. when I was over here on the left-hand side of my circle and I'd only gone about halfway around, I had this little bit extra in here. Well, this is pi radians and pi is 3.14. So that little bit extra is 0.14 of a radius measure. And I think that's interesting how those radius measures fit all along the circumference, and you have 2 pi of them. To convert between degrees and radians, you're going to use one of these two formulas. And this is something that you do need to memorize. 180 degrees is equal to pi. So you've got that ratio that you're going to use as a conversion factor, just like you would use 12 inches equals 1 foot when you're converting between feet and inches. These are the ratios that we're going to be using to convert degrees to radians and radians to degrees. All right, so let's look at problem number 3. Convert negative 480 degrees to radians. Start by writing down the number that you're given. And we are going to multiply this number times some fraction. And what I always like to do is look at the units that I start with. I'm starting with degrees. I want degrees to go away. I want them to cancel out. So I know I need degrees in the bottom part of my fraction. So I have 180 degrees in the bottom part of my fraction, and pi is going to be in the top part of my fraction. Now, what I would do is to put this in my calculator as just negative 480 over 180. So if you hit alpha and then y equals, you get your fraction template that comes up. Once you have the fraction entered into your calculator, you can just press enter and you get that fraction of negative 8/3. So your answer is actually going to be negative 8 pi over 3. We have to stick that pi in there. If you were to put that pi into your calculator when you did the rest of that fraction, you're just going to get a decimal approximation, and that's not what we want. Okay, problem 4. I'm starting with radians, so I have pi over 6 radians, and I want to change to degrees. So I want to end up with degrees, so I need to have degrees in my numerator. I'm going to have pi in my denominator, and the pi's are going to cancel. So you can put this in the calculator. 180 divided by 6 is 30. So this is going to end up being 30 degrees. Here I have 5 pi over 7 radians that I'm converting to degrees, and I'm going to round to 2 decimal places. I'm going to be multiplying by 180 degrees over pi. So the pi's are going to cancel, so you could just put 5/7 times 180 into the calculator, and you're going to get approximately 128.57 degrees. Problem 8, we're starting with 121 degrees, and we want to change that to radians. I want degrees to cancel, so I need degrees in the bottom part of my fraction. So I would put this in my calculator with the pi symbol in here because I don't want an exact answer. I want a decimal answer rounded to 2 decimal places. So you just stick all of that into the calculator and you get approximately 2.11 radians. I think that of most everything in this first chapter, this is one of the things that I like the most. My directions here to say to draw the angle in standard position, state the quadrant in which the angle lies, and work the exercise without converting to degrees. Now, one of the reasons why I like this so much is because I think it gives you a better understanding of what a radian measure is. And I think the more that you do these type of problems, I don't know where my picture went. Okay, the more that you do these type of problems, the more understanding that you're going to have of radian measure. first problem that we're going to look at, we have theta to be pi over 8. The first thing I'm going to do is to label this as 0 radians and this is pi radians. I know 180 degrees is a straight line, and I also know that 180 degrees equal to pi. The next thing I want to do is to pay attention to this denominator. I'm looking at 8s. So what I want to do is write this angle measure of pi is 8/8 pi, or 8 pi over 8. I'm going to take the top part of my coordinate grid and divide it into 8s, and I'll take the bottom part of my coordinate grid and divide it into 8s. Actually, I'm going to do that at the same time. I know that halfway, or this 90-degree angle here, the y-axis, is going to be 4 pi over 8, because 4/8 is 1/2. You can see that I have half of these angles labeled. If you wanted to or you needed to, you could go all the way around. We are asked to sketch pi over 8, or 1/8 pi. So I've got my initial side of the angle, which lies along the positive x-axis, and our angle is positive, so we're going in a counterclockwise direction. And we are in quadrant 1. Okay, problem 10. Again, we're going to start off by labeling this as pi. Look at my denominator. I have 4, so I'm going to label this as 4/4 pi. I'm going to divide this top part of my coordinate grid into fourths. So I have 1/4 pi, 2/4 pi, 3/4 pi, and 4/4 pi, and then 5/4 pi is down here in quadrant 3. Go ahead and write that down while I'm thinking about it. This is my initial side. This is my terminal side that lies in quadrant 3. And we are going in a clockwise direction. So I have a positive angle there of positive 5/4. Okay, on problem 11, you can see I've already divided my grid into 8 sections for the part that is above the x-axis and 8 sections that's below the x-axis. And notice that my angle measure here is negative, so I need to be going in a clockwise direction. So this would be negative 1/8 pi, this is negative 2/8 pi, and so on. So I have all of my angles labeled that I need to. I'm going to draw in my initial side, then negative 5/8 is here, and I am going clockwise, and I am in quadrant 3. In problem 12, you can see that I have the top half of my graph divided into 6, and I want to sketch in pi over 6, and that is in quadrant 1. Sometimes when you're sketching in thirds, it's a little bit harder to do, because you want to tend to use this y-axis as one of your lines, but you're not. When you're dividing into thirds, you're going to have a steep line with a positive slope, a steep line with a negative slope. So you have 1/3 pi, 2/3 pi, and 3/3. So 4/3 would be down here in quadrant 3. Now problem 14 is interesting because we have a number here that's actually going to give us more than one full rotation. We're still going to start off by dividing our grid into 6. Now, I'm not going to label all of these because it's starting to get a little bit messy, but you can see I've got 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11, 6, 12, 6, and 12, 6 pi is the same thing as 2 pi. 2 pi is one full rotation. So 13 pi over 6 is this angle here that is in quadrant 1. But remember that we have gone all the way around and then back again. So we need to be sure that we put that arrow in there when we have negative measures, when we have measures more than 2 pi, or when you have an obtuse angle, just to be sure that you're clarifying which direction that you're going.